Hello, welcome to Ekidel. We are a twin future civil and structural engineer. My name is Justice Moka and I am your instructor. Today, I will be showing you life load reduction for a high-story building. So, by the end of this video, you will be learning how to apply life load reduction whenever you are designing for a high-rise building using Protastructure 2022 version. Okay, so right now as you can see, this is the 16-story building design. As we promised here on Ekidel that this 16-story building project will be one of the complete high-rise building project or design that we will be doing here on Ekidel, and we will do or perform this design up to a pi foundation. So if you are a follower of Ekidel, or if you're new on Ekidel, I would say that this project should be one of your number one for you to follow us up on this design project. So for you to follow us up on this design project, I would say that you should check on this video description and then download this CAD file. This CAD file, the link to this CAD file is on every video description of this 16-story building, beginning from the part 1, and currently we are on the part 9. So you can quickly get the CAD file of this. As you can see, the CAD file, it has all the plans, as you can see that. So get the CAD file from the link down below. It is not free and it's not also expensive, but for you to be able to follow us up and then be grounded, I would say you need this CAD file to get all what we are offering here on this 16-story building right here on Ekidel. Okay, so right now we will now move on to the design or what we have for today, which is the life load reduction. Now, on my previous video on this project, which is on the part 9 of this video, I showed you guys how to apply life load reduction by just exchanging the type of slab from the solid slab by using a waffle slab or a rib slab. So in this case, we chose to use a rib slab for just to be able to reduce the weight of that solid slab. Now on this other video, which is the part 10, I'll be showing you how to apply now the life load reduction, knowing basically that in any building in real life, it is not let me say that in a real life now, in all situation, when a building construction has, let me say, finished, all the parts of the building will not be loaded at the same time. When I mean that it will not be loaded at the same time, let me say if people are on the bedroom, and you will see that either the lobby will be free from human load or free from human activity. So in that kind of case right now, it is being specified in the code that when you're designing for a high-rise building, we should apply life load reduction. So in that course now, I will now be moving on to the life load reduction. Okay, so if you have followed us up to this part now, and you have also inserted either your waffle slab or your roof slab, then let's now move on to the next step on how to reduce or how to apply life load reduction. So life load reduction can be applied by you clicking on this place here that says stories here, this icon that says stories. Now on this icon that says stories, now you now go this again down below here, and then you will see story edits. Okay, so we will now go here and click on story edits. I will explain more about this life load reduction. So if maybe you didn't get what I just said before, just hold on, I will explain that. Now why this is loading, if you have not clicked on the subscribe button and if you have not given this video a thumbs up, I would say you should please give this video a thumbs up so that this video can go viral here on YouTube, and also subscribe to our channel so that you don't miss any of our amazing coming videos based on design of structures. Okay, so right now you can now see this interface that says edit story. Now I know that most of you are very conversant with this interface where we have to apply our story height. That was when we were on the part 5 or part 4. We came to this interface where we applied our story height. Now on this same interface, it is also the same place where we have to apply load reduction. As you can see on this column right now, on this column right now says impose load reduction, as you can see that, and it is being showed by 0. So we will have to apply the percentage on how we want to reduce the load based on the stories. Okay, as you can see that we have a total number of 17 stories. So, and also if you check on this percentage here, they are all showing 0, 0, 0 up to 17th floor, right from the first floor here. Okay, so right now you can see on this other place that says impose load reduction. Now when I told you guys that in a real life situation, let me say you have let me just use a one-story building as an example, and a one-story building and also a residential building as an example, or let me use a very realistic explanation. Let me assume that in a school building, yes, in a school building. Now, if you have a school building, and I know most of you have passed through the four walls of school, either from high school and all that. When you were in your first year or in your high school, or let me say in your first year in your university, you know that there is always a time when there is time for lectures, and when it's time for lectures, everybody goes to the classroom and sit down to study, right? Now, in that kind of concept, now in that building, at that particular time where the students are having their lectures, you will see that the part of that building that is being loaded fully is the classroom. Is the classroom that is being loaded. So in like, let me say, in the time of from 8 a.m. to 2 p.m., the actual place around the building that is being loaded, or the area of building that is being loaded, is the classroom, while the restroom and the lobby is not loaded compared to as much as the classroom hall is being loaded. That's because all the human activities, all the people are being gathered in one place to study. That means that the load on that particular place is very, very loaded, while the lobby is not loaded. The lobby or the walkways are not that loaded with human activities. Now, in that course right now, you will see that the percentage imposed load, or the life load percentage based on the lobby or the walkway compared to that of the classroom hall will work different. Different in the sense that the load at that particular time is being concentrated in one particular place, which is the classroom, while the walkway and the lobbies and the restroom might have just 1 or 2 persons that is trying to come to the classroom, or that is outside, maybe not feeling fine, I don't know, and all that. But the concept is that in a whole structure or in a whole building, there will be a time where there will be much life load either on the sitting room or on the restroom or on the bedroom, while some other areas of the structures will be free, or at least will be free, or let me say minimum free from the imposed or life load. Now let me also say in the area of let me say your own personal building now, or let me say for a registered building, there will be a time, let me say from 6 p.m. in the evening up to 9 p.m. in the evening or in the night. You will see that the whole family will gather either at the sitting room to watch movie, because that is the time they want to rest from work activities and all that. Now from 10 or from 11 p.m. to 5 a.m. in the morning, you will see that the sitting room will be free, because nobody, or let me say, if there are 5 persons watching movie as at 8 p.m. to 9 p.m., from 10 p.m. to 5 a.m. in the morning, you will see that either one person will still be there watching movie, while the rest people have gone into the bedroom to go and sleep. Now, at that particular concept now, you will see that the area that is heavily loaded is the bedroom, because the people are having their rest, while the lobby and the restroom are free from imposed load. From, let me say, when I mean imposed load, I mean human load right now. We have several type of imposed load, but for human activities first, I want you to understand this concept. That's why I'm using human activities and all that. Okay, so at this particular time, you will see that when they are all sleeping, the lobby is free from human activities. So it was from this concept that they now use to apply this load, imposed load reduction. Although there are other concepts too, but I just use these human activities to be able to break it down to your own simpler understanding. Okay, so right now you will see that in this 16-story building hotel right now, yes, during it is very rare, or it is very okay that the whole rooms will be fully occupied by humans activities. But even if the whole rooms in this 16-story building is being occupied by human activities, there will be a time when all the lobbies, all the restroom might be free from human activities and all that, because they are all in the room resting. So in this kind of place right now, you will see that the life load around the lobbies and most areas where human activities are not operating at that particular time is less. So in the course of us trying to reduce the load on the structure, because as your story goes higher and higher, you as the engineer must find a way to reduce your load, which we did on the part 9, where we have to convert that solid slab to waffle slab. Now in this other case, this one right now is like a composite thing for you to do, which is a life load reduction. Now if I apply this life load reduction now, you will see that this area here that is showing 0 will now be showing percentage. Okay, now we can choose to edit each of the percentage if we want to edit that based on how we want it to be. So if I now come here right now and then apply here, you can see now that we now have that on the story 1, you can see that on the story 1 has 50%. So you can see that there is a 50% load reduction on story 1 up to story 6. Okay, story 1 and story 6 have the same life load reduction of 50%. Now when it comes to story 7 has 40%. Story 7 to story 12 has 40% life load reduction. The same thing. Now on story 13 has 30% life load reduction, and on story 14 has what? 20% life load reduction, and on story 15 has what? 10% life load reduction, and on story what? 16 and 17 is being given as what? 0%. Now you can see that from what I just explained to you guys, this is the kind of concept that was used to apply these life load reductions by percentage. That is what they assumed. As you can see that each of the stories have different percentage. Okay, so as your story goes higher and higher, you will see that this software we use the current code that you are using, either EuroCode, British code or Indian code and all that, and then apply the life load reduction. Because even if when we are doing manual calculations and all that, and then manual design, we used to apply life load reduction and all that. Okay, so that is basically the whole concept on how to apply life load reduction. Okay, now also, if you are not okay, let me say, a good software should give the user or the engineer leverage to impute his or her own value. Okay, so right now you can see that this software has given you, based on the code, EuroCode that we are using, you can see that it has now applied the load reduction by 50%, 40% and 30% and 20 and 10 based on the stories, and this other 16 to 17th floor are given as what? 0, 0. Now, if I, as a software engineer, I don't want to use, I don't want to have this place to be 0, I can quickly apply 5% here as at the 16th floor, and let me say 5% again here at the 17th floor. Okay, and if I'm not okay with what I have at this let me say 8 story here, 8th floor here, or let me say the this other side here, I can choose to apply this to a 12 at 30% and choose this one here as 25%. So you can quickly 25%. So you can apply that based on but I would say that before you can apply or do this by yourself, you must have understood about life load reduction properly. But if you don't understand it, I would say that you should just rely on the software. So for the purpose of teaching software, and I don't know the level of understanding that most of the people watching this video has, I will have to use the one that the software gave. But if I am the one that is performing this structure, let me say, without me doing this video, and I want to apply that based on my own experience, I will come here at this story 1 and put 75%, and I'll come here and put 60%, and I'll come here 65, and I'll come here, leave that as 50, and I'll come here 50, leave that as 50, and then come here 45, and all that. Okay, that's how I want to reduce that. And when I come to this last floor here, I can choose this one to be 10%, and this 15% and all that. Okay, but for the sake of those people that don't understand this, because you don't have to guess these values, you must understand how you want to distribute or how I want to reduce your load based on the percentage. Okay, but if you don't understand that, okay, I would say that you should just click on reset. If you have done any changes, click on reset, and everything will come back to 0, as you can see that, and then apply it now based on the software given values, okay, which came from the design code, and it is okay. I can tell you that it's okay with that. Okay, so right now this is how to now apply life load reduction. I have explained how this concept came into existence or how it came about. Okay, then but if you're still confused, I'll say that you should just drop your comments down below, and I'll try to explain to you guys again if you're confused. And also we have WhatsApp platform created, which is called Ekidel Global WhatsApp Platform, where civil engineers ask questions and all that. And let me say, if you're performing a design and you're stuck in any place, you can quickly send a screenshot of what you're doing, and then fellow engineers here on Ekidel all over the world can just assist you on that. We run it's a very interactive WhatsApp platform. So if you don't have WhatsApp, I would say that you can get your WhatsApp app and then join the WhatsApp group. The link to that group is just below this video description, and then you can be able to join that, and then we can give you approval on that. Okay, so right now you can now see how we have applied life load reduction on our building, which is the 16-story building. I can see how each of the stories are being applied based on percentage. Okay, how the load is being reduced based on percentage. Okay, so right now I'll go ahead now and then click on what? Okay. So with this now, what we have, I'll say yes, apply. What we have just said now is that we have now applied life load. Sorry, let me just load this. We have now applied life load reduction on this. Okay. Now I told you guys that part 9 and part 10 will be on load reduction, which we have just done so far. On the part 9, which is the one we did last 2 weeks or last week, I showed you guys how we have to remove the solid slab to the waffle slab. And then on this part 10, I have shown you guys how to now apply life load reduction based on the reduction by percentage. Okay, and which we have just done so far now. So on the part 11, which we are going to move on to, we will be checking out for this, which is for this swimming pool design. As you can see that basically we have just done so far, we have basically this modeled for this 16-story building, but what we have also modeled for this area here, which is this double volume here, which you can see on this 10th floor around this place here. As you can see it here, we have modeled for that area, which is this area. As you can see that we have modeled for that. And this small slab, as you can see it here, this small slab area that is on this side here, we have also shown that we have also shown it here. As you can see, this is the area here, like a balcony. Okay, we have also done that, as you can see it on our design here, model here. So right now we will now move on to the design, the modeling of this swimming pool. As you can see at the top of the roof here, we have a swimming pool. We have an L-shaped swimming pool, as you can see that right now, at the top of the roof. Now, most of you have not really known how to model a swimming pool at the top of a building, and also basically in this software, Protastructure. It's quite a difficult thing to do if, let me say, even if you are a professional engineer and all that, you must have to consider some things and all that. So on the part 11, I will be breaking it down to the simplest form on how to model a swimming pool at the top of a roof and how you will have to carry your swimming pool. Knowing that a swimming pool must come with a retaining wall. As you can see that around this swimming pool should come with a retaining wall. And not only that, the next thing you have to consider is how do you want to carry your swimming pool. As you can see that this swimming pool right now is directly at the roof. As you can see that at the roof of this 16-story building. Okay, so how do you want to carry this your swimming pool and all that, and how do you want to how do you factor the load into the structure? So I will be showing you all that on the part 11 and part 12, because part 11 we will not be able to finish that part 11. So part 11 and part 12 should be on the swimming pool modeling, and also on the CAD file here on Storey 2. You can see that on the Storey 2 we have a hot bath around, a hot water bath here around this Storey. This is Storey 2 basically, yes, the second floor. So you can see that we have it around this area, although this hot bath is not a drop down kind of pool. It is an upstand pool. So we will just introduce a retaining wall, an upstand retaining wall around this area on our Storey 2, which is basically around this area. That should be Storey 2. That should be around this floor. This floor. So I'll be showing you that also, how to do that. That's why I say to be on part 11, part 12, and maybe 13 should be on the swimming pool modeling, because once we are done with this swimming pool modeling, then we will now move on to the structural analysis, because we have done everything. We have applied wind load. We have applied we have also applied life load reduction. We have applied loading combinations and all that, and then basically we will have applied seismic effect or seismic load, but this structure is not considered to be in an earthquake region like Albania, Italy and all that. So this structure is considered to be in an earthquake free zone region. Okay, so we will not consider earthquake or seismic load on this structure. Okay, when it comes to seismic design, I'll be showing you on that, maybe on a different structure altogether. So right now we are done with this part 11, sorry, part 10, right? Yeah, part 10, because part 9 and part 10 is on the design, on the life load reduction. Okay, so right now we will now be moving on to the part 11, okay, which will be on the next video, the next part of the video. And also I want to apologize for the delay of this part 10, because I think we have spent over 10 days without posting video, and we promised that we will be posting in 7 days maximum. Okay, but some things came up. We took most of our engineers out for studies and all that in Europe and in other countries, so that's why we are trying to plan for their arrangement and travel, but I think we were able to succeed on that. So that's why we have to delay for like 10 days or 11 days on that, but apologies for that. And I see you again right now on the part 11, which is coming out in less than 5 days. Okay, so see you again and God bless you. Now before you go, I will say that if you have not subscribed to our channel Ekidel, I will say please click on the subscribe button and also give this video a thumbs up, so that we can be able to get some ratings here on YouTube. And also, if you're a student or you're a colleague in any company, I would say that, and if you're benefiting here from Ekidel, I would say you should please share this video to your friends if you're a student, and also share this video to your colleagues so that they will also know how to perform structural design. Basically, most engineers are very stingy with knowledge, but I will tell you that it is not the right thing to do. To make the world a better place, I would say you should spread the knowledge. There's no need for you getting stingy with knowledge or keeping it all to yourself. Don't keep it to yourself. To make the world a better place, share the knowledge. The knowledge that you are saving for yourself, it might affect you tomorrow. And I always tell my boys, the people I train, that maybe you are keeping knowledge to yourself, and the person you now refuse to share knowledge with, now maybe God blesses the person, or by favor, the person got a contract to design and construct and also supervise a hotel building, a very massive one and a very beautiful one at that. And let me say that because the client was very good to him, there was no much eye on to check the stability of the structure, and the hotel, they have done with the construction and they have launched the hotel. And you right now, or let me say your wife, decided to travel to the country or to that region and now lodge in that hotel, not knowing that that hotel was not designed properly. And then something happened to that hotel, that there was a failure. Your wife might be badly injured, if not fatally injured, or death in that case. What happened? Yes, it is based on the structural failure because the engineer was not that competent enough to design that structure. But what just happened was that you were also among the cause because you heard the knowledge that you would have been able to transmit to the engineer to make the world a better place. You heard knowledge and then something bad has happened. So be free to everyone you see, be free to your colleagues, be free to everyone. This world, let's make it a better place. See you again on the part 11, and God bless to everyone watching Ekidel, and God bless to everyone sharing our videos to all their platforms and to their friends. We love you, and then see you again on the part 11. God bless you. Bye for now.